Alright, so this is my first video on forces. I'm going to do the same problem we did in class. And here you have mass 1, mass 2, trying to find what mass 2 has to be to move mass 1 with the tension at a 35-degree angle, like this. Okay, so first I drew free body diagram for mass 2, and it's the tension and the mass, the weight of mass 2. Here I know that the forces in the y direction are going to equal 0 because the mass is not moving, and we find that T equals m2g. And over here I drew a free body diagram of mass 1, and I know that there's a normal force, the gravitational force, the tension of the rope, and the static friction. So for the y component, I know that the normal force minus gravity minus the weight times cosine, because it's adjacent over hypotenuse, equals 0. And the x direction, I have the static friction plus the gravitational force acting in the same direction as the static friction, which is the weight times sine of theta minus the tension acting in the opposite direction. So we know that the static friction is equal to the coefficient of static friction times the normal force. So we start plugging things in down here. We know that the static friction is equal coefficient of static friction times the normal force plus m1g sine of theta minus m2g, which we got from the minus t. It's t equals m2g. And then we plug some more things in. We plug the what we got from the normal force up here. We know that normal force is equal to the weight of mass 1 times cosine theta. We plug that in here, and then we can cancel out gravity. We can cancel out gravity from each section because each one has one. We get to the final equation, which is mass 2 equals coefficient of static friction times mass 1 cosine mass 1 plus mass 1 times sine theta equals 0.45 kilograms.